This video is for Chapter 2, Molecules and Solutions, Part 3, Solubility and Concentration. First question, what do these substances have in common? Well, all of them are mainly made of water. So that means if you're drinking orange juice, well, there's no such a liquid as orange juice. You're actually drinking H2O, you're drinking water. So it's mainly water. And dissolved in that water is sugar, vitamin C, and other substances and minerals. If you're drinking Mountain Dew, you're not drinking a liquid that's called Mountain Dew, you're drinking mainly water, and dissolved in that water there's some food coloring, artificial and natural flavors, and mainly sugar, and also there's a gas in there. There's CO2 dissolved in Mountain Dew. So they're all made of water. 3.1. What is a solution? Well, a solution is a homogeneous mixture whose components cannot be distinguished. So if we had orange juice without pulp, we would only see one part in the mixture. Even though it's made from water, vitamin C, sugar, and other things, there's only one part that we can see, so it's homogeneous. While if we had orange juice with pulp, then we would be seeing two parts in the liquid, and we would have to call that heterogeneous. Most solutions are said to be aqueous solutions, meaning that they are made with water, from the Latin word aqua. In A, we can talk about the solubility of a solution. So solubility is the maximum amount of solute that can be dissolved in a given volume of solvent. Solubility is different from one substance to another. For example, the solubility of sugar and salt will be different in water. That means if we were to take two identical glasses filled with water and try to dissolve sugar and salt, so the amount of sugar would be different than the amount of salt that could be dissolved in the same volume of water. It is possible to dissolve solids like table salt, NaCl, in water, but also liquids can be dissolved in water. For example, ethyl alcohol, CH3CH2OH, is very often dissolved in water, or gases such as oxygen must be dissolved in water. Fish in water get their oxygen, which is dissolved in the water they live in. If you drink pop like Mountain Dew again, well, there's plenty of CO2 dissolved in that drink. Usually, solids increase their solubility as temperature increases. So that means if I'm going to boil water, I'm going to be able to dissolve a lot more salt than if I had water at room temperature. But gases increases their solubility as temperature decreases. So the colder it gets, the more gas can be dissolved in the water. So that means that for fish, for example, cooler water is a good thing because there should be more oxygen dissolved in it. And in B now, let's look at the different parts of a solution. First, there's the solvent. That's the main component where the solute is added. So for most of the examples we're going to look at this year, we're talking about water. So water will be our solvent because we're talking about aqueous solutions. And then the solute is the substance that is dissolved in the solvent. For example, sugar can be dissolved in water, CO2 can be dissolved in water, a type of alcohol can be dissolved in water as well. And I want you to represent this in a diagram. So if we make one container, we're going to put a solvent. That solvent could be water. And to be called a solution, I need to add a solute. For example, we're going to add some, hold on, that's my salt shaker, so that's my solute. We're adding salt to the solution. So solute is here, salt in our example. So that would be a solution. Salt water, like seawater, is a solution. 3.2. Concentration of a solution. What makes a beverage more or less concentrated? Well, it depends on two things, basically. One, the amount of solute dissolved in that solution, and two, the volume of solvent used. So imagine if we use a lot of solute. So if we were making Gatorade from powder and you were adding a lot of powder, which is your solute, well, your concentration would go up. It would have a stronger taste. It would be more concentrated. But if we thought that the Gatorade mix was too tasty, like too sweet, we would want to add water, which is your solvent. So having a higher volume would reduce the concentration of that beverage. Now, what is the concentration of a solution? We're going to say that it's the amount of solute in a given amount of solution. And to understand, we can try to compare solutions A and B. In solution A, we have a volume of 1 liter, and we have 4 particles in 1 liter. So that would be the concentration, 4 particles per liter. And for solution B, we have 7 particles in 1 liter. So the concentration is 7 particles per liter. So which one is more concentrated? Solution B is more concentrated because for the same volume, 1 liter for each solution, there are more particles in solution B than in solution A. 3.3, changes in concentration. How can we reduce the concentration? Well, that's by adding more water, which is the solvent, and that would be called a dilution. So if you took a first solution with 0.5 liters and 10 particles, that concentration would actually be 20 particles in 1 liter, if I did have 1 liter. Now, if we add water up to 1 liter, the number of particles remains the same. We still have 10 in there, but it's over 1 liter. So the concentration was reduced by half because we increased the volume by 2. So those are inversely proportional. And you increase the volume, you decrease your concentration. Now, what if we did this now? I'm going to take some solution from that second container, and I'm going to pour a little bit into a smaller glass of water, which is only 0.2 liters. That's 200 milliliters. So I would have something like two particles per 0.2 liters. But what is that in 1 liter? Still 10 particles in 1 liter. So note that I have never changed my concentration. Just because I pour in a smaller glass does not change anything for concentration. Now, how can concentration be increased? That would be by adding solute. So if I'm making Gatorade, that would be adding the powder, and this is called a dissolution. So if I take a first container, volume of 1 liter, and I have 5 particles in there, so that's a concentration of 5 particles per liter. I'm going to add solute, okay? I'm going to add some more of that Gatorade powder so that I have 10 particles in 1 liter. And the volume hasn't changed here, but we have more particles per volume. So adding the solute increases the concentration. And what if, again, I was to pour some of that solution in a smaller glass? Now the volume that I have is only 0.5 liters. Has the concentration changed? I only have 5 particles in 0.5 liters, but if I turn that fraction into 1 liter, over 1 liter, I get the same concentration. It's still 10 grams per liter, 10 particles per liter. So again, pouring in a smaller glass doesn't change the concentration. 3.4, formula for calculating concentrations. Well, to obtain a concentration in grams per liter, you would be given that formula on an exam. So capital C is equal to small m over capital V, where C is concentration in grams per liter, m is the mass, always in grams, and V is a volume, always in liters. Please skip the next 2 slides and go to 3.7. Now let's do some unit conversions here. Remember, for volume, you could have to go from milliliters to liters, or liters to milliliters. If you start with milliliters and are looking for liters, divide by 1,000, because in the 1 liter you always have 1,000 ml. Guys, you'll have to know this one by heart, okay? That has to be known. And if you have liters, and want to turn it to milliliters, then you don't forget you multiply that number by 1,000. We'll also talk about mass in unit conversion. So this time we have three different units: milligrams, grams, and kilograms. There's a factor of 1,000 between each of them. So it's the same idea as for volume. When you're going from milligrams to grams, divide by 1,000. And from grams to kilograms, divide by 1,000 again. That means if someone wanted to go directly from milligrams to kilograms, you would have to divide by 1,000 and then divide by 1,000, by 1,000, or if you prefer, that's dividing by 1,000,000. And you will get your conversion done right away. And now if you want to go from kilograms to grams, you multiply by 1,000, and grams to milligrams, you multiply by 1,000 again. And I want to look at this example with you. What if we had 0.2 kilograms and wanted to know how many milligrams is that? Well, I could do it in two steps. Step one, if in 1 kilogram we have 1,000 grams, then in 0.2 kilograms, and know that I have to keep my units the same. If on top I have kilograms, here I need kilograms as well. So how many grams is this worth? So to show my work, I have to do 1,000 grams times 0.2 kilograms divided by 1. You can cancel units. Like that, you know that you're really ending up with the right unit, which is grams. That's what we were looking for. So that's 200 grams. Step number 2, go from grams to milligrams. So same deal. I know in 1 gram I have 1,000 milligrams and I have 200 grams. So that's a lot more than 1. I have to do times 200, so that's why I'm going to do 1,000 milligrams times 200 divided by 1 gram. So my final answer is 200,000 milligrams are equal to 0.2 grams. If you prefer, you could do it in one step. If you remember that in 1 kilogram, there are 1,000,000 milligrams, so that's going to be done in one step only.